Welcome back to Cosmic Earth, your home for the strangest corners of physics. Imagine riding your bicycle down the street, and suddenly, the entire world starts warping around you. Colors shift from vibrant reds to deep blues as you pedal just a little faster. This isn't a sci-fi dream, but what would happen if the speed of light slowed down to a crawl? Right now, light travels at a blistering 300,000 kilometers per second. It is the absolute speed limit of our universe, keeping cause and effect in perfect order. But what if that cosmic speed limit suddenly dropped to just 30 miles per hour? The consequences would completely erase how we experience reality every single day. In our normal universe, we never experience Albert Einstein's relativity because we move way too slow compared to light. But if light crawled at highway speeds, everyday life would become a trippy physics playground. Walking to your local grocery store would suddenly trigger extreme relativistic effects. You would feel the fabric of space and time bending around your body. The first thing you would notice is a bizarre transformation of colors. This is known as the relativistic Doppler effect, which shifts light frequencies based on your motion. As you walk toward a green traffic light, the light waves compress, turning the green into a deep violet. If you step backward, the waves stretch out, shifting the color to a warm, glowing red. But your eyes would see things far stranger than just shifting colors. An effect called Lorentz contraction would warp the actual shape of everything around you. As you walk past parked cars, they would appear incredibly narrow, squished like vertical pancakes. To a stationary observer, you would look like a paper-thin cardboard cutout moving down the street. These bizarre visual distortions were first calculated by Einstein in his special theory of relativity back in 1905. Physicist George Gamow later illustrated this beautifully in his famous science book series about Mr. Tompkins. In these stories, a fictional character explores a fantasy world where the speed of light is extremely slow. The science behind these mind-bending concepts is entirely accurate according to modern physics. Time itself would also behave in ways that feel completely unnatural. This is because of time dilation, where moving clocks run slower than stationary ones. If you jogged around the block for 10 minutes, you would return to find your family has aged significantly more than you. A simple morning run could turn into a one-way trip into the local future. Another wild phenomenon you would experience is called the searchlight effect. As you speed up, your field of view would slowly bend forward, concentrating all light directly in front of you. The world behind you would fade into pitch black darkness, even in the middle of a sunny day. You would literally be tunneling through a beam of concentrated light. While these optical tricks sound like a fun amusement park ride, the underlying physics would soon turn catastrophic. The famous equation E equals mc squared dictates how much energy is locked inside matter. In this formula, E represents energy, m is mass, and c is the speed of light. If you drastically reduce the value of c, the energy holding atoms together collapses. This drop in energy would instantly affect the nuclear fusion powering our sun. Stars rely on the immense energy output of mass converting into pure light to fight off gravity. With a tiny speed of light, the energy released from fusion would drop to almost nothing. The sun would fail to support its own weight and collapse instantly. The very atoms that make up your body would also face a major crisis. The electromagnetic force that binds electrons to atomic nuclei relies on virtual photons traveling at the speed of light. If light slowed down, the strength of these electrostatic bonds would weaken dramatically. Matter as we know it would lose its structure, causing solid objects to dissolve. We actually have real-world examples of particles moving faster than light in specific mediums. When particles travel through water, they can exceed the speed of light within that medium, which is slower than in a vacuum. This creates a brilliant blue glow known as Cherenkov radiation, similar to a sonic boom. In a slow light universe, walking down the street might make you glow with this eerie blue light. To understand why this happens, we must realize that the speed of light is actually the speed of causality. It is the maximum rate at which any event in the universe can influence another event. If you stub your toe, the electrical signal traveling to your brain cannot exceed this fundamental limit. In our slow universe, you would feel the pain of an injury minutes after it actually happened. Sending signals would become nearly impossible across even short distances. A phone call to a friend in another city would take hours for the signal to arrive. Sending an email across the ocean would feel like sending a letter by wooden ship in the Middle Ages. Our globalized, high-speed digital world would instantly grind to a painful halt. Why is the speed of light set to its exact value of nearly 300 million meters per second? Physicists still do not have a definitive answer to this fundamental question. It is one of the fine-tuned constants of nature that allows our universe to support complex life. If it were even slightly different, the universe we see today could not exist. In the 19th century, scientists believed light needed a physical medium to travel through, which they called the luminiferous ether. The famous Mitchell-Morley experiment in 1887 proved that light travels through the vacuum of space without any medium. This groundbreaking discovery paved the way for Einstein to realize that the speed of light is constant for all observers. This constancy is what makes our universe stable and predictable. If the speed of light were slow, exploring our universe would become an impossible dream. Even with our current technology, reaching the nearest star takes thousands of years. If light speed were 30 miles per hour, traveling to the moon would take weeks of continuous flight. The stars in the night sky would become forever out of our reach. Even simple household appliances would stop working in this strange world. Microwave ovens rely on high-frequency electromagnetic waves to heat up your food. With a slow speed of light, these waves would have incredibly long wavelengths, making them useless for cooking. Your kitchen would become a graveyard of non-functional technology. The behavior of fire would also change in ways that defy our daily expectations. Combustion releases energy through chemical reactions that depend on electromagnetic interactions. If these interactions slow down, fires would burn at an agonizingly slow pace, barely releasing any heat. Keeping warm during winter would become a massive challenge for survival. Our brains would face the ultimate challenge of processing this slow-motion reality. The synapses in our brains fire using electromagnetic signals that travel near the speed of light. If this neural communication slowed down to a crawl, our thoughts would become incredibly sluggish. It might take hours just to formulate a simple sentence. The nature of shadows would also behave in highly counterintuitive ways. In our world, when you move your hand, your shadow moves almost instantly. In a slow light universe, your shadow would lag behind your movements like a bad internet connection. You could walk away from a wall and turn around to watch your shadow catch up to you. In this slow universe, the speed of sound would actually be much faster than the speed of light. You would hear a glass shattering on the floor long before you saw it hit the ground. This flip in sensory order would completely scramble our brain's ability to coordinate sight and sound. We would live in a world where echoes arrive before the images. Even the beautiful blue of our sky would undergo a dramatic transformation. Rayleigh scattering, which makes the sky blue, depends heavily on the wavelength of incoming sunlight. With a slow speed of light, the scattering of solar radiation would shift completely. The sky might turn a deep, dark red during the day, while sunsets could become a bright, blinding green. The collapse of thermodynamics would also be thrown into complete chaos. Heat is simply the kinetic energy of vibrating atoms and molecules. Since these vibrations are governed by electromagnetic forces, heat transfer would slow down to a crawl. Hot coffee would stay boiling hot for days, while ice would take weeks to melt. Interestingly, scientists have actually managed to slow down light in real-world laboratory experiments. In 1999, physicist Lean Howe successfully slowed a light beam to just 38 miles per hour. She achieved this by passing the light through a supercooled cloud of sodium atoms known as a Bose-Einstein condensate. This incredible breakthrough showed us that the speed of light is not always completely rigid. A few years later, the same research team managed to stop a beam of light completely inside a medium. They stored the light's information inside the atomic states of the gas and released it later. This mind-blowing experiment opened up new possibilities for quantum computing and advanced data storage. It proved that we can manipulate the most fundamental speed limit of the universe under the right conditions. On a cosmic scale, a slow speed of light would change our view of the night sky forever. When we look at distant galaxies, we are actually looking back in time because of the time light takes to reach us. If light traveled slowly, we would see nearby stars as they existed millions of years ago, rather than just years. The night sky would become a slow-motion movie of ancient history. The expansion of the universe would also look vastly different to our astronomers. The redshift of distant galaxies, which tells us how fast the universe is expanding, would be magnified. We would perceive the universe as expanding at an unbelievably rapid rate, even if it was not. This would make calculating the age of the cosmos nearly impossible. This thought experiment reminds us of the delicate balance that governs our entire reality. The fundamental constants of physics are perfectly tuned to allow stars to shine and life to flourish. Altering just one of these values, like the speed of light, completely unravels the fabric of existence. It shows us how deeply interconnected every single law of nature truly is. If you enjoyed this mind-bending journey through physics, make sure to hit that like button and subscribe to Cosmic Earth. Share this video with your friends to see what they think about a slow light universe. What mind-expanding topic should we explore next? Let us know in the comments below, and we will see you in the next video.